All right, we're gonna get you guys started right away here. First thing, anytime you guys see that a direction says to factor, you should have a key set of things that you think about right away. The very first thing that you think about should be, can I find a GCF? Can I pull something out? So we have to look at it, whether it's a binomial, trinomial, if it's just a regular polynomial, so 4, 5, 6 terms, always see if you can pull something out of it first. So is there a GCF? The second thing that you're always going to do. Second thing, if it's a trinomial, we're automatically going to go straight into our x. Okay, so our diamond method is what that's called for factoring. So we do our a times our c up top. We do our b on the bottom. We always split it. And the biggest thing you have to remember when we do this, and I'm going to write an example over here, if it would be like 3x squared plus 4x minus 6, if it would be something like that. Whatever this term is, so we take the coefficient plus the variable, that is what we always write here. So I'd write 3x and I'd write 3x. For the past 2 or 3 days, everything you guys have had has looked like this. It's been just x squared plus 3x plus 2, something like that. So you've only had the one x that you would put in there. Now you have a number in front that you have to make sure you add in as well. Phone's ringing right now. All right, so we're gonna put this to the test right away here. If I look at our first example, it just says factor. So if I take factor the very first step, I'm going to look at, can I pull anything out of it? Is there any type of GCF? So between these three terms, right away I look at it and say, all right, I can divide everything by 4. If I divide by 4, I'm left with n squared plus 12n plus 11. Okay? The biggest thing you have to remember now, you factored out that 4, so that 4 has to be in your final answer for your factor. So I'm going to write it down at the bottom. It's going to be 4 times whatever my two factors turn out to be. All right, so back to my factoring. If I have my trinomial here, I make my x. See, all right, I have just that n squared, so I'm going to write 1n on here for both of them. I know that's what's going to start both my factors. And a times c, so 1 times 11 is 11. My b term is 12. So what multiplies to get 11, but adds to get 12? It's got to be 11 and 1. So my factor turns out to be 1n plus 11, so n plus 11, and n plus 1. That would be factoring. Okay, so that's one example just where you have to pull out the GCF. Second example, we're going to try and make it a little bit more difficult if we can. I need to see a problem first. So we're going to go to Alright, I want you to write this one down for me. I can get it back. Alright. 10x to the third power. That's a 3 up there. I don't know if you can see it. It's a pretty ugly 3. Minus 68x squared. Minus 96x. Okay? So that's going to be our trinomial we're looking at, and I'm going to write the direction just so you see it. I'm going to say I just want to factor this. All right, so first step in factoring, can you pull out a GCF? If I look at this, I see they're all even, so I know I can divide out of 2. If I would keep going back through and looking at to see what else there is to pull out, there is no other number that goes into all 3, so I know 2 is the biggest number. I also noticed they all have at least an x, so I'm going to factor out a 2x. So that leaves me with 5x squared minus 34x minus, what would that be, 48. Okay, so now that is a big problem. All right, so I remember now, since I factored out a 2x, I'm going to go down to the bottom and just write it so I remember 2x times whatever my two factors are. And then I get into my x. This term, again, is always our first term up top, so 5x. Our b term always goes in the middle, negative 34. Then a times c goes up top. So if that was 50 times 5, it would be 250, so that should be 240, negative 240. Negative 240. So I figure out what multiplies to get negative 240 and adds to get negative 34. So for this one, we're going to have a little bit more thought into here. My first thought, what would that be? Negative 240 and 34. So I'm going to do a little cheat method just to show you, or tell you at least. I'm going to go into the calculator to y equals. If I'm not sure what multiplies to get negative 240 and adds to get 34, on your calculators, if you click on y equals, I'm just going to put 240 divided by x. So my equation says y equals 240 divided by x. If I press second graph, it's going to take me to the table, and that table has every single factor that goes into 240. So in this case, I see 1 and 240, 2 and 120, 3 and 80, 4 and 60, 5 and 48, 6 and 40. I know that 6 and 40 has to be it in some way, and it's got to be a negative, so it's got to be a negative 40 and a positive 6. So when I write these factors, currently my factors would be 5x minus 40 and 5x plus 6. Okay? If I look at this one, 5x plus 6, there's nothing I can divide out of 5x and 6. I know that that one's perfectly fine, so I'm just going to write down here 5x plus 6. For this one, I see a 5x and a 40. I know I can divide both by 5, so I do. And that ends up giving me x minus 8. So that shows me my second factor should be x minus 8. So again, we went through this entire scenario here where we had to pull out a greatest common factor first. We pulled out 2x. Then when we looked at it, we had our first time where there was a number in front of our x squared. We had a 5 there. The only difference then is we wrote 5x in both of our factors. If we can reduce an entire factor, we do. It gives us the x minus 8 down here, and then we're completely set. We end up with 2x times 5x plus 6, x minus 8. That is it. There is a worksheet full of practice problems up here on the front table. If you need it, come on up and grab.